Hello everyone. Today we're talking about inductive and deductive reasoning. And just a reminder folks, these numbers here, chapter 2.1 and 2.4, refer to your online textbook that you can access through your student portal by clicking on the McGraw-Hill icon. Should be a little red icon, McGraw-Hill Education and or McGraw-Hill Connect Ed to see the online textbook. So let's get down to business. Functionally, inductive and deductive reasoning are two ways to allow us to make conjectures and process information about the world. To start things off, inductive reasoning is reasoning that uses information from different examples to form a conclusion or a statement. These statements are called conjectures. Think about it in terms of looking at a pattern and predicting what comes next based on that pattern. For instance, write a conjecture about the next number in the sequence of 1, 3, 9, 27, 81. Well, it looks like that for each one of these, it's 3 raised to a specific power. 3 to the 0, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, and then 3 to the fifth, which would be the number 243. Deductive reasoning, in contrast, uses facts. Think about like Sherlock Holmes. We're using facts, rules, and definitions to reach logical conclusions from given statements. That is to say that every time Monica goes to the store on Wednesdays, she buys a gallon of milk. Monica goes to the store on Wednesday, so she concludes that she will buy milk. Basically, if an idea is valid, then the statement is true. All right, some problems. So, a stray animal comes up. Determine whether each conclusion is based on inductive or deductive reasoning. A stray animal comes to your house 4 consecutive nights. That sounds like a pattern. You predict it will come on the 5th consecutive night. Well, because we have this pattern, 4 consecutive nights, and a prediction based on that pattern, we're going to say this is inductive. Since all squares are rectangles, and all rectangles have 4 sides, then all squares have 4 sides. Well, this is based on a true statement that all squares are rectangles, and the true statement that rectangles have 4 sides, to come to another true statement that squares have 4 sides, making that deductive. You've always gotten a birthday card from your grandmother, so naturally you expect to get a birthday card this year from your grandmother. Well, once more, it's a pattern. You've always gotten a birthday card. Naturally, you expect to get a birthday card. Based on the previous pattern of birthday cards, you expect one this year. That would make this inductive. Jennifer always leaves for school at 7 a.m. Jennifer is always on time. Jennifer assumes then that if she leaves at 7 a.m. for school today, she'll be on time. Well, she always leaves for school at 7 a.m. She's always on time. That is a pattern of behavior. That means that this is inductive. All numbers ending in 0 or 5 are divisible by 5. The number 35 ends with 5, so it must be divisible by 5. Well, that's a fact that 0s and 5s are divisible by 5. It's a fact that 35 ends in a 5, so we can deductively reason that it will be divisible by 5. Moving on. How to solve inductive reasoning. It's all about patterns and looking for patterns. So for instance, we have this situation here where we've got 1 square, 4 squares, 9 squares. Write a conjecture about the number of small squares in the next figure. Well, it looks like to me that for each of these items, the sides are increasing by 1 unit. That is to say that the next unit, our conjecture, will be next item will have a 4 by 4 shape. Because 4 is 1 more than 3, this was a 1 by 1, this is a 2 by 2, this is a 3 by 3, so presumably the next one will be a 4 by 4. Inductively reasoning that out. All right. Your turn. Now for these folks, I'm going to pause a little bit before giving you the answer in case you want to work it out on your own. Alternatively, you can pause the video right here and work it on your own and then play the video again. So, write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item in the sequence. -5, 10, -20, 40. The pattern here is that the previous number is being multiplied by a -2. So the next number would be 40 times -2, or -80. 1, 10, 100, 1,000. Look for a pattern. Each term is being multiplied by 10, or adding a 0 to the end of it. So we're multiplying the previous thing by 10, which leads to our next term probably being 10,000. Write a conjecture about each value or geometric relationship. Angle 1 plus angle 2 form a right angle. There are a few things we could say about this. That angle 1 plus angle 2 is equal to 90 degrees. That these are complementary. Yeah. Angle 1 and angle 2 form a right angle. We can make conjectures that angle 1 plus angle 2 equal 90 degrees. They are complementary angles to each other by definition of complementary angles. Angle ABC and angle DBE are vertical angles. Based on the definition of vertical angles, we can make the following conjectures: that they have the same angle, that they are congruent, and that they are opposite angles. All right, moving on. Deductive reasoning. The law of detachment and the law of syllogism. Now these laws might sound familiar, maybe not by name, but by process, the things you learned about in pre-algebra, and that's okay. Sometimes in geometry you'll see some old ideas being rebranded and repurposed for geometry. So the idea of law of detachment. If P then Q is true, and P is true, then by definition Q must also be true. Example: determine whether each conclusion is valid based on the given information. If not, write invalid and explain your reasoning. Given: two angles are supplementary to the same angle are congruent. Given: angle A and angle C are supplementary to B. Conclusion: A is congruent to C. This statement, A and C are supplementary to B, is true. Because if we break it down, if P then Q, so two angles are supplementary to the same angle are congruent. So if A is supplementary to B and C is supplementary to B, then A must be congruent to C. Kind of like that problem we had on our review last week. Law of syllogism. If P then Q, and if Q then R, then P leads to R is also true. Example, the two conditional statements below are true. Using the law of syllogism, we're going to find out if we have a valid answer and state the conclusion. If a number is a whole number, so if P then Q, if P then Q, if a number is a whole number, then the number is an integer. And if a number is an integer, if Q, then it's a rational number, R. Therefore, we can conclude that if a number is a whole number, so if a number is a whole number, P, then it is a rational number, R. So basically here, if a number is a whole number, is our p-value, that number is an integer, that's our q-value. If a number is an integer, that's our q-value, it's a rational number, that's our r-value. So if p then q, and if q then r, then p leads to r. If a number is whole, our p, then it is rational, our r. A few more. Deductive reasoning and the law of detachment. Determine whether the stated conclusion is valid based on the given information. If not, write invalid. Explain your reasoning. Given, a number is divisible by 6, then the number is divisible by 3. 18 is divisible by 6. Conclusion, 18 is divisible by 3. Valid. This is a true statement. Given, if a pet is a rabbit, then it eats carrots. Jenny's pet eats carrots. Conclusion, Jenny's pet is a rabbit. This is invalid. Why? Well, simply because Jenny's pet could be another type of animal that eats carrots. Maybe it's a guinea pig. Maybe it's a cow. Maybe she has a pet horse. Number 3, given, if a hen is at Plymouth Rock, then her eggs are brown. Berta is a Plymouth Rock hen. Conclusion, Berta's eggs are brown. This would be a valid statement, as it follows our format. All right, your turn. Use the law of syllogism to draw a valid conclusion from each statement if possible. If no valid conclusion is possible, write no valid conclusion, or no answer, or undefined. Your choice here, really. Number 1, if an angle is supplementary to an obtuse angle, then it is acute. If an angle is acute, then its measure is less than 90 degrees. Well, this makes it a valid statement, because if an angle is supplementary to an obtuse angle, that angle itself must be less than 90 degrees. Because in order for it to be supplementary to an obtuse angle, it must add up with that obtuse angle to 180. The obtuse angle is, by definition, larger than 90 degrees, which means the other angle must be acute if it's going to be supplementary to that obtuse angle. Number 2, if an angle is a right angle, the measure of the angle is 90 degrees. If two lines are perpendicular, they form a right angle. This is also going to be valid. It's valid because if two lines are perpendicular, then when they intersect, they form a right angle at the point of intersection, and right angles have a 90-degree angle. Number 3, if you study for the test, then you will receive a high grade. Your grade on the test is high. Now, unfortunately, folks, this is invalid. Okay? It's invalid because there might have been other reasons for why your grade was high. Maybe questions were thrown out for whatever reason on the test. Or maybe you got lucky in guessing. The future does not imply the previous in this case. All right, almost done, folks. Just 2 more pages to go through, 2 more slides. A conjecture is false if there is even one situation in which the conjecture itself is not true or false. So not true / false. The false example is what's known as a counter example. Basically an example that proves the opposite. Touchpads. Find the counterexample in this example. Show that the conjecture is false. If points A, B, and C are collinear, then AB plus BC must equal AC. Okay, so the idea being that if points A, B, and C occupy the same line, they're collinear, such that AB plus BC is equal to AC, yeah? And that is true, but there's a counterexample, at least one other counterexample. Because what if our arrangement here isn't in alphabetical order, but instead we have the arrangement of A, C, B. We still have the true statement that A, B, and C are collinear, but now we have a situation where AB plus BC does not equal AC. Counterexamples. Now it's your turn. Determine whether each conjecture is true or false. Give a counterexample for any false conjectures. So number 1, if DE is perpendicular to EF, then angle DEF is a right angle. So if we have a situation where DE is perpendicular to EF, then DEF is a right angle. Well, that must be true. There is no counterexample. There's no way to set this up that we wouldn't have that occurring. Number 2, the sum of 2 numbers is always greater than the larger number. False. We can add with negative numbers. Let's say that while it is true that like 3 plus 5 is equal to 8, the fact that we can add a negative and therefore subtract a positive, like if we had, for instance, negative 3 plus 5, well, that's the same as 5 minus 3, which is equal to 2. So the sum of 2 numbers is always greater than the larger number. Well, the larger number in this case is 5. 2 is not greater than 5. 2 is less than 5. So we'd say this is a false statement. Okay, looks like the formatting got a little messed up here. That's supposed to be if x squared is equal to 4, then x equals 2. This is a false statement. Because if you remember from Algebra 2, if we have x squared equals 4, that means x is equal to plus or minus the square root of 4. So x could be equal to 2 or negative 2. So So the idea of x equals -2 would be the counterexample to our statement. And that, folks, is all of our notes for today on inductive and deductive reasoning. We'll go over more examples tomorrow for an activity. Take care.